So its pressure gets drastically decreased. So the output here is, so when the refrigerant passes through this expansion device, the pressure gets decreases. So output is low pressure, low, very low temperature liquid. The phase transformation doesn't take place inside the expansion device. It only reduces its temperature and it reduces its pressure, but it doesn't cause a phase transformation. Okay, if the output from the condenser was liquid, the after the expansion, the phase change doesn't take place. It only reduces its pressure and reduces its temperature. So expansion device only doesn't cause a phase transformation to take place. Okay.
Yes, sir.
So now what is the output from our expansion device? What is the state of the refrigerant? It's low pressure, very low temperature. After expansion, if the refrigerant was at atmospheric temperature, suppose 20 degrees Celsius, after expansion its temperature gets very low. That is about minus 20 degree Celsius. So it is a very steep change in the temperature as well as very steep change in pressure as well. Okay, if it is here 10 pascals here, it may go here to 1 pascal. Okay, but one thing you should keep in mind, the pressure doesn't go below the atmospheric pressure at all times. The pressure doesn't go below the atmospheric temperature, atmospheric pressure. Okay, what is atmospheric pressure? 101.3 something kPa. That is the atmosphere. It doesn't go below that. Okay, the pressure should always be positive. It should come down, but always should be positive. Okay, if it comes below the atmospheric pressure, so we will go into the suction mode. Okay, so we should not go to the suction mode here. Okay, so what is our output here? Very low
Temperature, low pressure.
Okay, then comes the part
4.
we have to install a device where actual cooling of the substances take place. We have to feed this thing in another device called evaporator. Okay, this is our another device called evaporator. So the input side of the evaporator is very low pressure, very low temperature liquid, and this is the thing that absorbs heat from the substances. Okay, suppose we have a juice bottle here. Suppose it is at 20 degrees Celsius. We have an apple here that is at 30 degrees Celsius. We have here ice water at 5 degrees Celsius that are kept close to this evaporator. We know inside the evaporator the temperature is very low, that is about, okay, इसमें feed it minus 20 degrees Celsius हो रहा है. So if there is temperature difference between evaporator and these systems that are kept close to the evaporator, what will happen? If there is a temperature difference between two things, the heat transfer will automatically take place.
Yes, sir.
So the heat from these higher temperature bodies will directly get feed to the evaporator. Okay?
Sir.
Isn't it? So these will give their heat to the evaporator. While giving heat to the evaporator, the refrigerant inside the evaporator gets heated because of what heat that comes from these substances what we have kept inside the evaporator. So eventually their temperature will go decrease, will reduce. Okay. So whenever the heat is given to the low pressure, low temperature liquid, the temperature of the liquid refrigerant increases, but that absorbs what heat it absorbs. It will absorb the latent heat of evaporation. It will absorb
latent heat of absorption.
Latent heat of vaporization. So that the refrigerant now gets evaporated.
Yes, sir.
But temperature doesn't increase or decrease at that state. You already know while the latent heat is absorbed. What is latent heat absorption? It is that amount of heat that is absorbed by a system to create its phase change. Here the refrigerant was liquid feeding inside the evaporator. After absorbing the heat, it will absorb that much of heat that was required for its evaporation. And what is that heat called? Latent heat. So the evaporator absorbs the latent heat, the amount of heat that it requires itself to evaporate. It absorbs that amount of heat and gets evaporated. Is it simple or it is confusing? It is simple to understand. It absorbs that amount of heat that was required for it to convert itself into the vapor state. It was in the liquid state. After absorbing the heat from the heat sources, that was our food or any other item stored in that thing, it will evaporate. So the outside of the, what is the outside of the evaporator then? It completely gets evaporated inside the evaporator, but the temperature is still very low. Suppose the input was 20 degrees Celsius. After absorbing the heat from these things, its temperature will now increase, say about 12 डिग्री सेल्सियस, -12 डिग्री सेल्सियस. इस टेम्परेचर पे जो कि इसका रेफ्रिजरेंट का बॉइलिंग टेम्परेचर होगा, उसी पे तो बॉइल होगा ना. प्रेशर कम है तो बॉइल इजीली होता है. लो प्रेशर पे बॉइलिंग इजी हो जाती है, वेपराइजेशन इजी हो जाती है. कब? लो प्रेशर पे बॉइलिंग, तभी ये लो प्रेशर पे जल्दी इवापोरेट कर जाता है. ठीक है. सो the refrigerant will start evaporating. The outside of the evaporator, what was the input to the evaporator was low pressure, very low temperature, liquid. Now what will be the output from the evaporator? Vapor. It will be low pressure because it doesn't affect the pressure that much. Pressure maybe increases a little bit, but not into except मतलब prominent level पे प्रेशर का चेंज, ड्रास्टिक चेंज प्रेशर में नहीं आता, ना ही टेम्परेचर में उतना ड्रास्टिक चेंज आता है. थोड़ा सा आता है क्योंकि हीट तो एब्जॉर्ब की है ना. फॉर एग्जांपल 30 या 40 डिग्री का लीप नहीं आता है. सपोज 5 to 10 डिग्री का लीप आ सकता है. ठीक है. सो हियर व्हाट विल बी द आउटपुट फ्रॉम हियर? लो प्रेशर, लो टेम्परेचर, लेकिन इस टेम्परेचर से ज्यादा क्योंकि हीट एब्जॉर्ब की ना. लो टेम्परेचर वेपर. अब वही किसमें फीड होना है?
फिर से कंप्रेसर.
दैट इज अगेन फेड टू द कंप्रेसर. एंड हियर द प्रेशर इज low because it sucks it from this side, from suction line. Okay, the compressor sucks that vapor from suction line and delivers it through the discharge line. And this is the basic cycle of the refrigerator. And this system may have also installed any other accessory device. That is, sometimes before the expansion device we have installed a filter here. I will discuss, but that is not important from engineering perspective. That is a helpful device that is installed. Maybe sometimes here is dryer fitted. Sometimes we attach a receiver here, an accumulator here. There are accessory devices also installed in the refrigerator. These have very good effect on the refrigeration system. But basic function needs only these four items. That is compressor, condenser, expander and evaporator. अब मान जैसे गाड़ी चलने के लिए टायर और इंजन जरूरत है, ये सिस्टम मानो वैसा ही है. ये चीजें होनी है. और फर्दर आप उसमें आप सस्पेंशन अच्छा लगाओ, उसमें आप मतलब लाइट्स लगाओ, वो चीजें है उसके लिए फायदा. मगर इम्पोर्टेंट वैसे ही ये वाली एक्सेसरी, चाहे हम फिल्टर लगाए, ड्रायर लगाए, रिसीवर लगाए, एक्यूमुलेटर लगाए, उससे हमारी परफॉर्मेंस इंक्रीज हो जाती है और इफेक्टिव बनता है. लेकिन वो जरूरत नहीं है, बस वो फंक्शनिंग के लिए इम्पोर्टेंट, और अगर लगाएंगे तो अच्छा ही है. लेकिन बेसिक रेफ्रिजरेशन का जो साइकिल है इसको हम बोलते हैं. देखो आपने कितनी जगह इसका फेज चेंज होते हुए देखा. कंडेंसर में फेज चेंज हो गया, यहाँ पे भी फेज चेंज हो गया. तो इसी वजह से इसको बोलते हैं वेपर कंप्रेशन साइकिल, क्योंकि हम वेपर को यहाँ पे फोर्सबली कंप्रेस करते हैं। दैट्स व्हाई इट्स कॉल्ड वेपर। वेपर को कंप्रेस जहाँ पे किया जाता है उस वाले साइकिल का नाम वेपर कंप्रेशन साइकिल है। और ये एक रेफ्रिजरेशन साइकिल है। क्या है? रेफ्रिजरेशन साइकिल। ये रेफ्रिजरेशन साइकिल है। ठीक है, एंड दैट इज ऑल फॉर टुडे। We will going to discuss this in more in detail, more professionally. That is on the another day. Okay. Thank you.